All right, everyone, get ready for a deep dive today. We're tackling AWS Associate Exam questions.
Ooh, sounds intense.
It is, but in a good way. We're not just about passing the exam here. We're going for true understanding. Really getting these AWS concepts, like having those AWS architects right there with you, sharing all their secrets.
I like that. No rote memorization, just a solid foundation.
Exactly. So picture this.
Yeah.
You're in the exam, feeling confident, and then bam, question 99 hits you. It's a migration challenge. You've got this company running a Windows application, but it needs a shared file system like their old server setup. What's the AWS solution that makes this move smooth?
This is where Amazon FSx for Windows File Server steps in.
FSx for Windows File Server. Okay, I'll admit the name's a mouthful. What is it and how does it help?
Think of it as creating a fully managed file server right there in the cloud, but it's specifically made for Windows, so it integrates with your Active Directory, making that migration much smoother.
So we're not reinventing the wheel, we're just taking that shared file system idea and putting it in the cloud.
Exactly. You get the familiarity of file sharing, but with all the scalability and reliability of AWS.
Nice. Speaking of things that need to work together seamlessly, question 100 throws us a curveball. We have an application that needs to access S3 and DynamoDB, but here's the catch. All traffic has to stay within the VPC. No public internet allowed. Security first, right? How do we make that happen?
This is where VPC endpoints come in. They're the key to secure private connections.
VPC endpoints. I'm intrigued, but the name doesn't give me much to go on. Help me visualize this.
Okay, imagine you have a private office building. That's your VPC. Now you need to access resources in another secure building, like S3 or DynamoDB. Instead of going out onto public streets, you build a direct secure tunnel. That's your VPC endpoint, a private pathway just for your traffic.
So we bypass the public internet entirely. Clever. But S3 and DynamoDB are different services. Do we use the same kind of endpoint for both?
Great question, and this is where it gets interesting. There are two types, gateway endpoints and interface endpoints. Which one you choose depends on the service you're accessing. Understanding the difference is key.
Okay, so it's not one size fits all. We have options, but all this security, it can't be free, right?
Well, let's look at question 101. It talks about an image processing workload that's costing a lot in data transfer fees between ECS and S3. How can we optimize that without compromising security?
Sounds like a dilemma.
It doesn't have to be. Remember those interface endpoints? They can actually help reduce costs because the data stays within the AWS network. So you get enhanced security A&D potential cost savings.
Win-win. Now that's something I can get behind. But let's move on from the world of VPCs for a bit and talk about something every website owner worries about: traffic spikes.
Always a challenge.
Right. Question 102 paints a picture. A website gets bombarded with traffic every day at noon. But users are getting timeout errors. Why? Because the application takes a full minute to boot up after autoscaling launches a new instance. How do we fix this without making users wait forever?
This highlights that autoscaling alone isn't enough. We need to look at the bigger picture. The answer here lies in using CloudFront with an application load balancer as the origin.
CloudFront and an ALB. I know those are powerful tools, but how do they work together to solve this?
Okay, think of CloudFront as your front line. It's a content delivery network that caches static content closer to your users. So a lot of the website content is already preloaded. This reduces the load on your origin servers.
Like a server that's already prepared with the most popular dishes.
Precisely. That gives your new EC2 instances that crucial 1 minute to boot up and join the ALB pool. Then the ALB distributes incoming traffic smoothly across all those available instances, ensuring everything runs without a hitch.
So it's teamwork. CloudFront handles the initial rush, giving auto-scaling and the ALB time to do their thing. But sometimes scaling isn't about handling traffic spikes, right? Sometimes it's about performance. Like in question 109, we have an application with slow read operations, even though the EC2 instances are fine. What's the game plan here?
This points to a bottleneck at the database level. We need to make those read operations more efficient, and that's where read replicas for your RDS instance come in.
Read replicas? Are we making copies of the entire database? Sounds resource intensive.
Not quite. A read replica is a read-only copy of your main database, constantly updated. Think of it like adding express lanes to a highway. Your main database handles the heavy lifting, the writes. The read replicas handle all those frequent read requests, keeping things moving quickly.
So we're separating the traffic for better flow. Makes sense. But let's talk data. Lots of data. Question 112 throws us into a migration scenario. A company needs to move its on-premise data to the cloud, but they also need fast access from their on-premise apps. What AWS solution bridges that gap?
That's where AWS Storage Gateway comes in. Specifically, the file gateway configuration.
Storage gateway. Is it literally a gateway between the physical and the cloud?
You got it. It acts as an NFS file share on-premise so the company sees what they're used to. But the data is actually stored in S3, giving them all the benefits of the cloud.
Sneakily introducing them to the cloud's power. I like it. But of course, we can't forget about cost. Question 125 throws us a cost optimization curveball. We've got an online video platform, and their storage costs are going through the roof. They're using EFS standard, which is great for performance, but getting expensive with all their data. How do we optimize their spending?
This shows why picking the right storage service matters. EFS standard is great, but for massive data volumes that aren't accessed all the time, it might not be the best. We need to look at transitioning to AWS Storage Gateway for files.
Wait, storage gateway again. It does migration and cost optimization. That's impressive.
It's quite versatile. In this case, Storage Gateway for Files provides tiered storage. It keeps frequently accessed data on-premise, while less frequently used data gets archived affordably in S3, like having a smart storage manager that knows where everything should be.
So we get the best of both worlds, performance and cost savings. This deep dive is already packed with insights. From VPCs and scaling to storage and cost optimization, we're uncovering these amazing AWS solutions.
And we've only just begun.
I know, right? It's like we're getting a sneak peek into how all these AWS services work together to solve real problems. It's exciting.
Yeah.
Buckle up, everyone, because this is just the beginning.
Onward to even more AWS discoveries. Welcome back to our AWS Deep Dive. These exam questions really get you thinking, don't they?
Absolutely. Each one is like a puzzle, but with AWS services as the pieces.
Speaking of puzzles, let's talk security. Question 105 focuses on something that seems simple but is super important. Rotating IAM user access keys.
Okay, rotating access keys. Sounds pretty straightforward. Why is it so crucial even if you're not a security expert?
It's all about minimizing risk. Think of it like changing the locks on your house. Even if someone had an old key, it wouldn't work anymore.
Ah, so it limits the damage if a key gets compromised.
Yeah.
Makes sense. But what about when you need to be extra careful? Like in question 106, where a company needs to block a specific IP address. We're talking layers of defense here, right?
Right. This highlights the importance of a multi-layered approach. The question mentions WEF, security groups, and NACLs. Imagine them like building a fortress around your application.
Okay, a fortress. I like that. How do these AWS services fit into the fortress analogy?
Well, WF, the Web Application Firewall, is like the outer wall. It's designed to block those common web attacks like SQL injection. It's your first line of defense.
So WEF stops those attacks before they even get close. But what if something slips through?
That's where security groups come in. They're like the guards at the gate, controlling traffic at the instance level. You set rules about what's allowed in and what's not.
So they're carefully checking everyone's ID at the door, but we need even more security for those really sensitive areas, right?
Exactly. That's where NACLs, or network access control lists, come in. They're like checkpoints within the fortress, controlling traffic at the subnet level.
So multiple layers of security checks, each one adding extra protection. But even with all that, we still have to watch out for accidental mistakes. Question 118 is about protecting S3 buckets from being accidentally exposed. How do we prevent those oops moments?
Automation and continuous monitoring are key here. AWS config and automation can work together to keep those S3 buckets secure.
How so?
AWS config is like a security auditor, always checking your AWS resources, making sure they're following the rules you set, especially for S3 buckets. It's constantly looking for anything that's out of place.
So it's like a security camera that never sleeps. But if it finds something wrong, do we have to fix it manually?
Not necessarily. That's where automation comes in. You can set it up to automatically fix those misconfigurations. Like if a bucket is accidentally made public, automation can swoop in and make it private again.
So it's not just watching, it's taking action. That's handy. We've talked about securing our applications, but what about securing our budget? Cost optimization is a big deal in AWS, and these exam questions definitely touch on that. Question 114 puts us in a situation where a company is running a third-party database server. The licensing cost is based on the number of vCPUs they use. How do we make sure they're not overspending on processing power they don't actually need?
This is all about right-sizing your EC2 instances. It's tempting to just go for the biggest, most powerful instance, but that often leads to wasted resources and higher costs.
So it's like choosing the right size engine for a car. You wouldn't put a giant truck engine in a tiny car.
Exactly. You need to understand what the database server really needs, the memory, storage, network
Huh.
performance, and then you choose an EC2 instance that fits those needs without going overboard on the vCPUs, which keeps the licensing costs down.
It's all about finding that sweet spot, enough power, but not too much. But as your AWS environment grows, keeping track of all those resources and their costs can get tricky. Question 126 addresses that with the concept of cost allocation tagging. Can you explain why tagging is so important for managing cloud expenses?
Tagging is like creating labels for your AWS resources, your instances, volumes, everything. You give them meaningful tags that help you track costs, usage, even ownership across different projects.
So it's like categorizing your expenses in a budgeting app. You can see exactly where your money is going.
Exactly. And AWS has tools that let you analyze your spending based on those tags. You can see exactly what's costing you money, and then you can optimize those costs and make sure you're getting the most value.
Makes sense. Tagging is like bringing order to the cloud chaos. But let's circle back to performance for a moment. Remember that question about the website with traffic spikes at noon? Question 102. Well, let's revisit that. Users are getting timeouts because the application takes a whole minute to boot up after autoscaling launches a new instance. How do we fix that without impacting user experience?
It's a classic problem. And the solution lies in combining CloudFront with an application load balancer, ALB, as the origin.
We've talked about CloudFront and ALBs before, but how do they specifically address this boot time issue?
Think of CloudFront as that super efficient waiter again. It caches content closer to users, so a lot of the website's content is already preloaded. That takes the pressure off your origin servers.
So while CloudFront is busy serving up the cached content, what's happening in the background?
Your new EC2 instances are taking that minute to boot up and join the ALB's pool of healthy servers. And the ALB is intelligently distributing traffic across those available instances, so everything stays smooth and responsive.
It's like a well-choreographed dance, with everyone playing their part perfectly. But scaling isn't always about traffic spikes, right? It can also be about optimizing performance for specific tasks, like in question 109. An application has slow read operations, even though the EC2 instances are fine. What do we do?
That points to a bottleneck at the database level. Adding read replicas for your RDS instance can make a huge difference for those read-heavy workloads.
We talked about read replicas earlier, but can you remind me how they work?
Sure, a read replica is a read-only copy of your main database, but it's constantly being updated. Imagine those dedicated lanes on a highway again. Your main database handles the writes, the heavy lifting. The read replicas handle all those frequent read requests, keeping everything flowing smoothly.
So we're separating those read and write operations for maximum efficiency. But let's shift gears and talk about data migration. Question 112 presents a challenge. A company needs to move their on-premise data to the cloud, but they still need fast access from their existing on-premise applications. How do we bridge those two worlds?
AWS Storage Gateway is the answer. It acts as a bridge between on-premise and the cloud, making data migration and access a lot easier.
We've talked about Storage Gateway before. It seems like a pretty versatile tool.
It is. In this case, we'd use the file gateway configuration. It looks like a regular NFS file share to the company's applications, but the data is actually stored in S3, giving them all the benefits of the cloud.
So they get the familiarity of their existing setup, but with the power and scalability of the cloud. Clever. But we can't forget about cost. Question 125 gives us a scenario where an online video platform is facing sky-high storage costs. They're using EFS standard, which is great for performance, but it's not the most cost-effective for their growing amount of data. How do we optimize their spending without impacting accessibility?
This highlights the need to choose the right storage service for the job. EFS standard is great, but for large volumes of data that aren't accessed constantly, there might be a better option, like transitioning to AWS Storage Gateway for files.
Wait, Storage Gateway again? I'm starting to see why it's so popular.
It can do a lot. In this case, Storage Gateway for files offers tiered storage. Frequently accessed data stays on-premise for fast retrieval, while less frequently used data goes to S3, where it's more cost-effective.
So it's like having a smart storage manager that knows where everything should be. We get both performance and cost savings. We've covered so much in this section: security, cost optimization, scaling, data migration. It's all connected.
It is, and that's what makes the AWS ecosystem so fascinating. It's complex, but it all works together, and we've only just scratched the surface. There's so much more to explore.
I can't wait to see what other AWS challenges we uncover in the next part of our deep dive. This is getting really interesting. And we're back for the final stretch of our AWS Associate Exam deep dive. It's time to put all our knowledge to the test.
I'm excited. This is where we see how all these concepts we've been talking about come together to solve real-world problems.
Right. Like in question 110, this one's all about going global. We have a company with facilities on multiple continents, and they need a distributed application. Orders placed in one region need to be visible everywhere else within a second. Plus, they need a database with super fast failover and high uptime. Talk about a challenge.
This is a perfect use case for DynamoDB global tables. It replicates your data across multiple AWS regions, ensuring low latency and high availability for those global applications.
Okay, global tables. Sounds impressive, but I'm imagining this massive web of databases. How does it all stay in sync?
Think of it like having multiple copies of your database, each one in a different region. DynamoDB Global Tables handles all the tricky stuff behind the scenes, the data replication, the conflict resolution. All those changes made in one region appear in all the other regions in a fraction of a second.
So no matter where you are, you see the most up-to-date information. That's pretty cool. But what about when we need a quick fix and migrating an entire application isn't an option? Like in question 111, a company has its website hosted on-premise, and they need to improve loading times for users in Europe, and they need to do it fast, but they don't want to move their whole back-end infrastructure. What can we do?
That's where CloudFront with a custom origin comes in. CloudFront is a content delivery network, so it caches content closer to users, which speeds things up. We can set it up with a custom origin that points to their on-premise servers.
So we're basically using CloudFront's global network to deliver content super fast to those European users.
Exactly. It's a quick way to improve performance without a major migration.
Smart.
Yeah.
But let's talk security again. Question 170 throws us a common scenario. We need to give a third-party vendor limited access to our AWS resources. We've got IAM policies in place, but what else can we do to be extra safe?
Service control policies, or SCPs, can add another layer of protection. They let you set guardrails at the AWS organization's level, preventing even those with high privileges from doing certain things or accessing certain resources.
SCPs. Okay, give me an analogy. My brain needs a picture.
Okay, imagine you're a company with a secure facility. IAM policies are like key cards, giving people access to different areas. SCPs are like the overarching rules for the whole facility. Like no one, not even the CEO, can access a certain server room without authorization.
So even if you have the keys, the rules still apply. It's like a safety net for those just-in-case scenarios. But managing security for a big organization can be a headache. Question 179 gets into that. A company needs to make sure CloudTrail logging is enabled across all their AWS accounts, present and future. How do they do that securely and efficiently?
This is a job for AWS organizations and SCPs again. By organizing accounts into organizational units, or OUs, and applying SCPs at the OU level, you can enforce those CloudTrail logging requirements across the board, no matter how many accounts they have.
So it's a centralized way to make sure everything is being logged, like having a security camera that can't be turned off.
Yeah.
But let's not forget about high availability. Question 190 takes us to a website launch. It's a new e-commerce site using a multi-AZ deployment of Amazon Aurora for MySQL. And they need to be ready for anything unpredictable traffic, the whole works. How do we make sure this launch goes smoothly?
This calls for an application load balancer, ALB, working in tandem with EC2 autoscaling. The ALB distributes traffic across multiple EC2 instances, and autoscaling monitors things and automatically adjusts the number of instances based on demand.
So it's like having a team of servers that can expand or shrink as needed. No matter how much traffic comes in, the website stays up and running.
Precisely. A robust, highly available infrastructure that can handle those launch day jitters.
Well, we've covered a lot of ground in this deep dive. From VPCs to global databases, security to cost optimization, we've explored so many AWS concepts.
It's been quite a journey. These exam questions have really pushed us to think deeply about how to build secure, resilient, and cost-effective solutions in the cloud.
And that's the beauty of this format.
Yeah.
It's not just about memorizing answers. It's about understanding the why, the how, and the when. It's about building those problem-solving skills that are so valuable in the cloud world.
Couldn't have said it better myself. Remember, the cloud is always changing, but the fundamentals remain the same. And with the knowledge you've gained from this deep dive, you're well on your way to becoming a true AWS expert.
Absolutely. So that wraps up our AWS Associate Exam Deep Dive. We hope you've enjoyed this exploration of the AWS universe. Keep learning, keep building, and until next time, happy cloud computing.